Buenas. First up, an apology to the people who I said were lying about the bulge. When I saw these programs coming up, I was pulling my hair out going, what are they talking about? What a load of rubbish. So I apologized to them because in my 1961 book of popular science, 1961, moon, earth, bulge. All right, how the attraction of the moon causes high and low tides. So straight away, 1961, how on earth did anybody work this out? Between 1961, we're talking what, 40, 50, 60 years ago, something, right? How did anybody work out that there was a tidal bulge on planet Earth, right? How? We have Newton, don't we? Gravitational stuff. So much noise, right? You try to make sense and you try to listen to everything that's going on. People saying this, people saying that, people calling rubbish, people throwing facts where they think are facts. But it gets real busy, right? Now, one of my personal observations, this is one of my personal observations. It doesn't matter about anything else right now, okay? You're in a boat, fishing, right? Whether in a river or in the ocean. They say the moon is orbiting us, spinning around us, we're turning, and it's creating the tides with its gravitational pull, right? Now, this gravitational pull, put it that way, not that it would matter with the gravity, it doesn't matter whether we're upside down or on the side, does it? Let's put this up, right? So the moon is going, what was that? It's going around, right? And it's going from east to west, right? You see that? Yep. And it's creating the tides. Wherever it goes, there's this bulge. Here's the question. Has anybody ever been anywhere on any ocean and been in a situation where the current runs one way, only one way, for forever, for 24 hours? Because this, if there was this bulge following the moon, there would surely come a time when somebody has witnessed being in a boat and the current only ever goes one way, right? In the high tides and the low tides, we get an up and a down. Every single time that happens, it comes up. But when it drops in the same direction that it came from, doesn't it? How does that work? How does that work? How does that work with a moon that is orbiting us? We're spinning. It's not like the moon stops, right? And goes, all right, time to go that way now. And it drops. And then it goes, right, let's go this way again, up and down. It's going one way, isn't it? It's supposed to be some kind of, even though it's rough and the terrain and the everything, right, on the planet, bulge, isn't there? So this is coming around like this, and we're spinning that way, right? So it's bulged. I mean, somehow it's going that way, isn't it? Why is it? For example, me personally here and in Florida, right? Fishing, boats. The current comes up from, I'm sure it's from the north. I thought about this. It'll be out there. It comes up, you can feel the current, the anchor's pulling, the boat's pulling, the lines are going, it's a pain in the arse. Then it stops. You have to slack water for a while. And then it goes, it drops, but it's dropping in the same direction that it came from. How? How does this work? How does the tide come to the top, have a half an hour of nothing at all, right? And then drop back down the way that it came in? Now, how does that sound like a continuous bulge circling the planet? How come it stops and it stops at the bottom? All this current and the terrain and the trenches and the everything's. How is it possible that it comes up and it stops up to an hour sometimes, and then it can drop, goes back the same way that that water came, and then it drops, and it can stay for half an hour at the low tide, as we call it, and then it happens again? How does that tie in with a moon that is constantly orbiting our planet, creating gravitational forces on the water? How does that work? It doesn't really work, does it? How on earth are you going to get an hour? Let's not say an hour. Let's say half an hour at the top of every tide and the bottom of every tide. On average, let's say there is a half an hour of zero movement. Zero movement. Doesn't matter where you are on this planet. There comes a time when you're at the top of something, there's no movement. So what's happened now? Half an hour here, got all of these currents moving, shifting all over the planet, but here I am and nothing's happening. That's nice. And then it drops, but it goes back the same way that it came from. It doesn't matter what anybody else says about this. That does not sound like water being controlled by an external body that's orbiting us, does it? It cannot be. It makes no sense. So once again, I apologise to those people who I put their program on. I had a couple of voices come up, pretty sure that they would be recognised, but I apologise for that. I thought that was something that they made up, but it obviously isn't. It's something that was a thing in 1961, right? The tides, here it is. I see this, I apologise. Now, 1961, how was this knowledge acquired? How was this knowledge acquired? This bulge, this, and it's all here, like they say, right? It's all here. So, here comes the other one. We have the different positions, don't we? We have a spring tide where the sun and the moon are in a line with Earth. Spring tide, it's a high tide. It's the higher of the tides. Then we have, that moon disappears. Now we're talking about this one. We get a neap tide. What is said, the gravitational force from the moon from the sun scrubs the gravitational pull from the moon out here, and that is why we get neap tides, lower tides. That doesn't make sense, does it? It doesn't. if the moon is here, pulling on the water there, and the sun is not in the picture, for example, so the moon is pulling on the water 1.3 seconds later. Enter the sun. So the sun's suddenly there with half of the gravitational pull, give or take, that the moon has. How is that gravitational pull going to stop? How does the sun, being there at a 90-degree angle, this is what they're talking about, right? How does the sun, with its gravitational, its half pull, somehow scrub that out? It's illogical. What would happen is you might have a bit more of a pull here, but you're also going to have a pull here, aren't you? So what you tend to see is a bit more of a bulge there in between the two. It's common sense. When does a gravitational pull cancel another one out? Lagrange, when you're setting a telescope up to one of the Lagrange points. So this one, this neat tide being low tides because the sun is counteracting the moon's gravitational pull, is rubbish. It's rubbish. If you've got two gravitational pulls, right angles to each other, acting on another body, they're not going to cancel each other out. It's stupid. Let's sack that one. We go over to here. So now we have another spring. So over here, this one and this one, this is the only one that makes any sense if there was a gravitational pull. Because they're both in line and they're both pulling on there. So yes, if this is the one that makes sense. Now this one skipped over to this side. So this moon is not there now, right? We have a moon there and the sun on the other side. They tell us it's spring tides again, all right? Now, is it logical to think that when this was over here, both pulling on this side, you know, height, massive height, Earth spinning anti-clockwise, centrifugal force or whatever, trying to push the water out. Now the moon is over here. Spring tides, high tides. Now, when it was over there, both of them pulling, creating quite a bit of chaos. Let's come over here. Now, obviously, there's not going to be that much of a pull there, so we can get rid of a little bit of that, right? Because the moon's over here. So the moon's over here, so it would be pulling a little bit more on this side than the sun, because give or take, it has double the strength. But doesn't this still pull a little bit on Earth, as they say, right? And the sun will be pulling back on Earth half of that, right? So they're not working together here, are they? They're not. They cannot be working as well as they were when the moon was there. It's impossible, because they're both on opposite sides of the water that's being shifted. So, there is something slightly out there. There is a speed bump, but it's hard to work out exactly. Look, one thing is for sure. When the moon is there, in line with the sun and Earth on that side, the gravitational pull, if there was one, is going to be more than when the moon is on this side and they're both working from opposite sides in a pincer movement, right? And then, of course, we go up, that moon disappears, and we have this right angle again. Now, for me, as the moon is coming down here, this would be some of the most chaotic times from here to here. This would be where the water is just... But no, they say here it's low. It's illogical. It makes no sense. It doesn't make any sense. Do you have... Where's my magnets? If you have a couple of big magnets, where are my magnets? Oh, there they are. Look. Okay. So we have a couple of magnets, right? Right. Let me just pause. All right, we're back. So this, I'm not sure. Those are probably going to be too small. Those tiny things there. So I've got a little selection. Now, sun and moon. See that? Right. So we've got the sun and the moon. Hang on. Now, right. Now, this would be, obviously, the most powerful one, wouldn't it? Boom! Right? That would probably still have helped that because it's common sense. So, then we go like, so that's Earth, right? If we go like this, no, sorry, this is the moon here. If we go like that, how is that going to decrease the pull there? It's not, is it? It's ridiculous. That's not gonna, it's still gonna pull because they say it's got half of the strength of the moon's pull. But this one is still gonna be pulling just the same. It's not going to make it weaker. And then we have the sun, Earth, and comes here. So what's going to happen here? The sun's further away. It's only got half of the pull of the moon. So it is not going to be as powerful as when they were in line, right? It's not. It's obviously the moon being a lot closer, it's obviously going to... Common sense. Do not tell me. It goes into that quarter where there's a right angle, sun, moon. This somehow cuts out the moon's pull, therefore we get low tides, the neap tide. It's illogical. It doesn't make any sense. It doesn't. See, this would always end up pointing north, which is that way. See it shift? Put these magnets well away. See how it shifts? If I put two, it's usually better. Strong, aren't they? Anyway, it's not about that. So, that's illogical. Now, the other one. There is. If you look at all of these things objectively, right, there is something going on this planet, let's not say planet, Earth, that is not making any sense when it comes to the water. It's not. These currents, these ups and downs. How can it be the moon if we've got this these patterns that don't coincide with the moon. They don't. It's been taught. 1961. How on earth did, look, in 1980, they didn't even know what was making the currents. Do they know now? Or are they just making it up? There is something going on. And it doesn't matter what anybody else says, right? It's about your own personal observations. There is no way to think that the tide coming in, rising, if you're out fishing or whatever, whoop, comes up, and then it drops. It stops for half an hour and then goes back the other way. That doesn't happen. If it's a moon dragging a bulge around, it doesn't happen. Something else on this place, wherever we are, is displacing the water. It goes up. It stops for a while, and then it drops, doesn't it? There is water being displaced. It is not being dragged around. It's not being dragged around. Nothing indicates that it is when you look at it like this. So, if the moon was creating the tides, it would come up. The boat would be here. It would come up from one way, and then it would just go that way, carry on, and the boat would drop. But it doesn't. It comes up from one way, stops, half hour, cigarette break, drops back down the other way. It's not a logical thought. It's highly illogical. Now, it's actually about common sense as well. It is. You cannot tell me that the moon is swinging around us, pulling a bulge, that mysteriously just everything stops depending where you are. Resonance and oscillations. I don't think so. It's not. Isn't logical. And why does it sometimes stop for 10 minutes, sometimes 40 minutes? What's that all about? The mood is shifting and all of these tides are shifting everywhere. It's illogical. It doesn't make sense that the smaller bodies of water, it doesn't make sense that the Gulf of Mexico, it doesn't make sense that the Mediterranean, it doesn't make sense that the 4 highest tides on the planet are all up north. If the moon is creating the bulge around the equator, does it? It doesn't. So again, I apologise to the people who I thought were lying about this bulge, but the question still arises. Are they not supposed to be smart? How could you teach that? It just means that people aren't thinking about what they're just doing like a parrot, aren't they, and repeating. I saw that and I had to teach that. I'd be going, hang on, excuse me, same as the pyramids. Excuse me, how did they get the first stone out with copper hand tools? Here we are talking about theories for how they built and the culture, and they used them for tombs, but we don't even know how they got a single stone out of any limestone freaking wall with copper hand tools. And then it just runs for generations, and everybody's like, guys, you need to reset and come back. Start looking at things properly. I'm not saying it's round or flat or anything in between, but these things, if you don't address them, you're always going to be going in the wrong way. This is not the moon. It's not the moon. It doesn't happen. You don't get these lulls. What does kind of, if you think about this logically, there has to be somewhere on this planet, I say planet, on Earth, right? Excuse that little mishap. This up and down this up motion, down motion. Here it comes that way and then goes back that way. I know it does. I remember being out the front. I remember I had to think about this properly. Every time you go out the front and it comes in from the left and disappears back away to the right. Comes in from the left and disappears back to the left. So when people trace that back, do an exercise, right? Somebody in China, somebody in India. So if this is the case, somewhere there will be a central place where the water's going and everybody's going up and then it's going back the opposite way. You'd think there would be a common denominator, unless there are a few of them, a few holes or something where it's coming up. What is for sure, right? It's no gravitational pull that's happening. It's just not. Just because the science says, the science was flawed from the beginning. 1961, it's the usual story, right? The shoulders of giants. It's Newton. If it was Newton, it's beyond question. Newton tells us, well, according to Newton's theory, seriously, needs to be a reset, and you need to look at Newton's stuff very closely, and Einstein's. All right, folks, I'm going to call this one now. It's not the moon. This isn't about gravity. There is something else on Earth displacing the water. It's coming up. There can be a pause of anywhere between a few minutes and nearly an hour of no movement whatsoever. And then it drops back and goes the same way that it came from. How can that be the moon? How can that be this rush of water that's the bulge that's spinning around the planet? Guys, it's not. There is something displacing the water on Earth, and it ain't the moon. It's something in the water. So close to coming to a slam dunk. Slam dunk. It has to be. It's not the moon. It's not the moon. If it were the moon, there would be a continuous flow. There would not be these lulls of dead water, of no movement, for close to an hour at the highs and the lows. Right? Not to mention the other bodies of water hardly moving, not to mention the slackness in the Gulf of Mexico and the Mediterranean. They're not too far away from the equator. There's no equatorial bulge whatsoever. And, like I said, where's that book? This, we know, goes at least as far back as 1961. Right? These are the things that people are not listening. There are no shoulders of giants, folks. It's liars and charlatans. All right, folks. Laters.